Hey guys, welcome back. Today I just want to refresh those polygons that we covered yesterday to assure that you have them down as we get ready to move forward and begin practicing with them. This is your warm-up today, so we're only going to do two together as a class. I'm going to do this one and I'm going to do this one with you. Everything else is going to be kind of on your own, and I want you to kind of figure out how to go about doing it. This first one here, you have a 1, 2, 3, 4, 5, 6-sided object, which is also known as a hexagon, right? It is not a normal regular hexagon that you'd be used to, but you can definitely see that it is a hexagon nonetheless. And if you look at this hexagon, you'll notice that it is a convex hexagon, because when we look at this, you can see that none of the lines extend into the interior of our polygon. So that is a convex hexagon. Next, we're going to take a look at this object here, and this is going to be a 1, 2, 3, 4, 5-sided pentagon object here. So this pentagon is a 5-sided object here, and it does meet our concave definition because as I draw two lines here, you can see I'm crossing into the interior. No, only two of them do, not all of them do, but that still makes it a concave polygon. So hopefully that helps as we get going today. Quick reminder, just kind of, you get the ECA coming up. It's important that we get ready for that. So polygons are a plane figure, meaning that they are two-dimensional, that is formed by three or more common sides such that no two sides with a common endpoint are collinear. No two sides with a common endpoint are on the same line is what that means. So it's important to remember that they can't be on the same line, so you get to lose some of those shapes like the hourglass shape that we looked at yesterday. Each side intersects exactly two other sides only at their endpoints. If it crosses over in the middle, it's not a polygon. There's kind of that extra excess there. These are also why curves don't work in polygons. You cannot have curves in polygons. So I want you to take a moment and identify these polygons. Please press pause. Great. Now that you've identified these polygons, let's go over them together. So what we kind of see with this one is we see a 1, 2, 3, 4, 5-sided pentagon here, right? And it's enclosed, and there's no weirdness to it. So yeah, 4 is a polygon. Yes. Right? 5. Oh, what's this? We got a curve. Curves don't work in polygons. This is not a polygon. And last but not least, we have number 6. Number 6 is not an enclosed figure, therefore number 6, not a polygon. So hopefully you've had a chance to do that. Now, looking at the next set is the names of polygons, the things that we call polygons. Again, remember to try to call quadrilaterals quadrilaterals. I know you may slip up and call them a square or a rectangle or a diamond or a rhombus or a parallelogram, maybe even a trapezoid. But you still have to identify them as quadrilaterals. They all fit within that. And we looked at a couple of these, and remember that the anagon just stands for any number. So an 11-sided figure would be called an 11gon. We don't have another name for that. Identify these figures for me. Please press pause. Okay, welcome back. Hopefully you've taken a moment to identify these. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, that's our 11th one, and that's an 11agon. Alright, so pretty original name there, but it's there nonetheless. Next one we have 1, 2, 3, 4, 5, 6, 7 different sides. So this becomes known as a heptagon. Alright, or a 7gon in some math books, but we'll call it a heptagon because that's the one that we identify with. Last but not least, we have this one, which has 1, 2, 3, 4, 6, 7, 8, 9, 10. That's a 10-sided figure, so that's known as a decagon. Alright, and that's how you would go through and identify these last couple. Polygons are convex or concave. A polygon is convex if no line that contains a side of the polygon contains a point on the interior of the polygon. Use this example to see convex. As you extend those lines, nothing crosses into the middle, and that's what makes it a convex polygon. on the opposite side, if a line does contain a point that lies in the interior, it is said to be concave. Use this to kind of see what a concave one looks like. I want you to take a moment and I want you to identify these couple as if they're concave or convex. Please press pause. Welcome back. Hopefully you had a chance to identify these as convex or concave. All right, I'm going to count up sides too just for the practice. 1, 2, 3, 4, 5. This is a pentagon here, right? So we have a 5-sided pentagon here, and as I extend my lines, nothing except for my poor penmanship is crossing into the interior of this polygon. This is a convex polygon. Now this one here is a 1, 2, 3, 4, 5, 6, 7-sided heptagon. And as I extend my lines, I'm seeing, okay, first one's, oh, no, you know what? Automatically now, I know this is a concave polygon because it crosses over into the interior here, which would be where we want to not have it. Now this last one is a little unique because it is slightly different. We have 1, 2, 3, 4, 5, 6, 7 sides again. So it's another heptagon. But as I go and I do this, most of my lines work. In fact, my longest lines work without issue on being a convex one. But my 2 shortest lines, if you extend them, go into the interior right here at the edge, which makes this a concave as well. These polygons that are regular are both equal angular and equilateral, and that's important to remember. They must have the same measure of angle, and they must have the same measure of their side lengths. Take a moment to look at these. Please press pause. Hey, welcome back. So hopefully you took a moment to look at these and see that you have answers for these. For this first one here, right? 4 sides of equal length. That's good. That's a good start, right? We've got a chance here. Unfortunately, these 2 angles, the 4 angles here, don't quite equal each other. So we have acute angles and we have obtuse angles, which makes this not regular. Next, we take a look at this and we have an acute angle up here, an acute angle and an obtuse angle down here, plus our sides are of different lengths. So this one is also not regular. Last but not least, we have this one. This one fits all of our criteria for being regular. It is a regular polygon. Diagonals can be drawn across a polygon to form more parts of it so that we can calculate the angle measure. So to go from a polygon here, we're going to create a diagonal from 2 non-consecutive sides, or vertices, excuse me. A consecutive vertice would be on this line here, okay? So while we can see that it's there, it's not forming that diagonal. Now, diagonal might be important for you if you like the idea of having a big TV, because that's how most of our TVs are measured these days. So when we cut a polygon into a half, specifically when we cut a quadrilateral, we're creating 2 separate triangles, each with 180-degree measures. So we now kind of have an idea about what is going on with that. So when I do this again, and I give you those 2 triangles here, what in the world do you think these 2 could equal up to? If you can remember that each triangle is 180 degrees again, we can just simply add the 2 measures together. So 180 plus 180 equals 360, and that is our measure of quadrilaterals. All quadrilaterals equal 360. You can take angle 1, angle 2, angle 3, and angle 4, add them all together, and you're always going to get 360 degrees. And that's really important to remember. So I want you guys to take a moment and practice these 3. Please pause. Hey, welcome back. I'm going to do this one so that you can kind of have that thrill of practicing on your own as well. So hopefully you had a chance to practice this and practice the other couple and set these up. So the first thing I'm going to do is I'm going to take my given information, my 100, my 84, my 2x, and my 2x. I'm going to go 100 plus 84 plus 2x plus 2x equals 360. Now that I have that, I want to take a moment to combine my like terms, and I'm a big fan of highlighting, underlining, making sure that I can quickly see the differences there. 100 plus 84 is 184 plus 4x equals 360. I tried to color coordinate on this just to kind of make it a little bit easier. So the next thing we're going to do is we're going to subtract 184 in a way to isolate x. And now that those are canceled out, we have 4x equals 156. So now that we have 156 in place, the next step is to isolate x even further, divide each side by 4, and x comes out to equal 39. So if I need to find the measure of those two, what I will do is I'll take this 39 and I will plug it in for x. So I will have 2 times 39, which would give me roughly 78. So each of those measures is 78 degrees. So here's your exit ticket for the day. Make sure this gets done before you go, and I will talk to you later. Thanks for watching. Have a good one.